Okay, last two examples for section 4.5, number 7 and number 8 with our max-min word problems. So on number 7, we are given 600 meters and we're used to enclose two rectangular areas that share a wall. And what dimensions will maximize the area? So let me just kind of draw a little rectangular area, and they're sharing a common wall. And our constraint is that we have 600 meters. So I'm going to call our widths here x, and I'm going to call our lengths y. And if we have 600 meters used to enclose those two rectangular areas, then I know that the 3 x's plus the 2 y's would have to equal the 600. We think of like our perimeter. And we want to know what dimensions will maximize the area. Again, max, min, largest, smallest, keywords that we should be focusing on the vertex of our quadratic. So we have our constraint equation. If we want to know dimensions, what dimensions will maximize that area, well, we know that our area would be equivalent to taking x times y. That would give us the area of that entire region. But we don't want to be working with two different variables, so we're going to use that constraint equation to solve for one variable in terms of the other. I'm going to work with x's, so I'm going to solve for y in terms of x. So 2y is equal to 600 minus 3x, and we're going to divide by 2, and so my y is equal to 300 minus 3/2 x. So our area equation I could think of as area is equal to x times 300 minus 3/2 x. And instead of writing area, I'm just going to switch that to a for area. So my equation coming down below over here is a of x is equal to, and I'm just going to start multiplying it out, FOILing it out. I'm going to have 300x minus 3/2 x squared, and if I just switch that around and put that in descending order, a negative 3/2 x squared plus 300x for our equation. And again, we know that our a term is negative, which means that we know that our parabola should be opening downward. Our vertex, that HK, is going to be the highest point. So the fact that they're asking about a maximum, and we know that our vertex is a maximum, our equation makes sense for the question that is being asked. So we have lots of points on this graph. We plug in an x, we get out a y, though I did not use y, I used a of x, so I plug in an x, I'm getting out an a of x. In words, our x, well, our x in our picture over here were sides of our rectangular area. They were our widths, so that was a dimension in our rectangle, and our a of x was our area. So every time we plug in a dimension, we are getting out an area. And HK is just another XY point on our graph. It just happens to be that highest XY point on our graph, that top point on our graph. So if we want to know something about a dimension, we should be focusing on H. If we want to know something about area, then we should be focusing on K. And the question that we were being asked is what dimensions? So that means if we're looking for what dimension, then we want to be solving for the h of our equation, the x of our vertex. Well, we know that the x of our vertex is that minus b over 2a. Our b here is the 300. And our a term is the negative 3/2. And so x is equal to a negative 300 divided by a negative 3, and we get 100. So we want to know what dimensions. Well, that is only one side of our dimension. To get the other side, we need to go back to where we were defining our other side, which was our y. And so our y is equal to 300 minus 3/2 times 100. And that is 300 minus, that's what, 150. And we get 150. So what dimensions will max our area is if our rectangle is a 100 meters by 150 meters. Those are our dimensions. If we wanted to know the max area, we could find that out and we could just multiply our two dimensions together. Okay. On number 8, our last one here. So suppose that the following demand function relates the selling price, P, in dollars, of an item to the quantity sold, which is X representing the number. So our price is equal to a negative 1/3 X, number of items sold, plus 40. And we want to know for which value of X will the revenue be a maximum? And again, that key word, maximum, minimum, smallest, largest, we want to be thinking of our vertex of our quadratic. Now, our revenue would be the number of units that we are selling, so the number of units, number of items, times whatever our price. You take the price times the number of units that you're selling, that would be the amount of revenue that you are bringing in. So we have our price, and our units we know is X. The number of items we sold is X. So in this case, if we take our units times our price, our revenue, and I'm just going to use R for revenue, would equal the number of units, the number of items, times our price, which was the negative 1/3 X plus 40. Or if I multiply that out, that's a negative 1/3 X squared plus 40X. And again, look at our A term. Our A term is negative, which means that our parabola is definitely going down, and that vertex is that highest point. So the fact that they're asking something about a maximum makes sense to our equation. So we have lots of points on our graph, and those points are XY points, but I didn't use Y, I used R of X. So we plug in an X, we get out a Y, we plug in an X, we get an R of X. X was the number of items, right, was our units, and R of X was our revenue. And HK is just another XY point on our graph, but it just happens to be that highest point on our graph for this particular graph. So if we want to know something about the number of items, we should be focusing on H. If we want to know something about the revenue, then we should be looking at K. So we are asked for what value of X will the revenue be a maximum, and then we're computing the corresponding price, unit price, and the maximum revenue. So in terms of our value of X, will the revenue will be a maximum, so the number of units, well, we know that the X of our vertex is a minus B over 2A. In this case, our B term is 40, and our A term is a negative 1/3. And if we take 40 divided by 2/3 or times 3/2, we are going to get 60. So we have 60 units, 60 items. And in terms of our revenue, if we go in our revenue equation and we plug in that 60, R of 60, we get a negative 1/3 times 60 squared plus 40 times 60. And 60 squared is 3,600 times a negative 1/3 is a negative 1,200 plus 2,400. So we get 1,200 for that maximum revenue. And I think we are good. So I will let you stop there.